Welcome to the next video. Today we will learn how to write an algorithm for the stack. So here an important thing to understand is there is no access built-in data structure like stack. We are going to implement the functionalities of stack on array. That means whatever the properties stack have, that is last in first out, we are going to implement that using array. So here we have considered this one stack, which is nothing but an vertical representation of array. So we have the name array here is ARR, whose locations are from 0 to 4, that is of size 5. Similarly, this is an vertical array whose name is stack and which is also of size 5 and whose indexes are from 0 to 4. So this is nothing but an array to which we have given the name as stack and with sizes of 5. So to start the algorithm, first we'll declare the array. How do we declare array? We write the data type, that is integer, array name, and then size. So this is the name of our array. So we are going to use the same, but instead of array, for our better understanding, this is our stack. So we'll name our array as stack for our better understanding. So this is my stack, which is also an array. So next important step here is to initialize a variable called as top. And this top variable will always be initialized to -1. So this top variable will be used to perform and push and pop operations on the stack. So currently it is pointing to -1. So hypothetically that means my top is pointing to -1. That means my stack is currently empty. So no any elements is present on the stack. So next we'll write an push operation. So we'll take a void and push operation. Suppose I have to push an element 10. So in this, at the first step, currently my top is pointing to -1. Now I have to insert an element 10 into the stack. So first step is that you have to increment this top value, which is currently pointing to -1. So first step of the push method is to increment the top. That is top equals to top plus 1. Means the top, which was initially pointing to -1, now will point to 0. That is top equals to 0. And when after incrementing the top, now I'm going to insert my this 10 element into stack. So for this step, I'm going to insert this 10 into an stack. So how do we insert an element into array? We write like this. So we write array of 0 location equals to 10. So this 10 will be inserted into 0th location. Similarly, same we are going to repeat here, and instead of array, I'm going to write stack because the name of our array is stack. So stack of 0. So this 0 is nothing but the value of my top. So 0 stack of top equals to what I have to save? I have to save this 10. So I'll write here 10. So the first step will always be to increment this top value, that is top equals to top plus 1. And after incrementing, we are going to save our data into our stack by using this top as an index. So suppose I have to insert one more push operation. I have to perform one more push operation. So instead of 10 now, I have to insert 20. So I'll also change this part as 20. So now we'll come into push function. The first step is top equals to top plus 1. So the initial value of top was this 0. Now my new top value will be 1. So currently the new top value is equal to 1 after incrementing. So the top value, which was initially pointing to 0, now will point to 1. So after executing this step, we'll come to next. Next is stack of top equals to 20. So this will interpret as stack of top. What is the value of top? 1. Value of top is my 1. So stack of 1 equals to, what is the data? It is 20. So this 20 will be inserted into stack of index 1. So after coming here into the stack of 1 is this. So this 20 will be inserted into stack of 1. Now again, if we want one more push operation, now instead of 20, I have to insert 30. So I'll remove this entire thing. I'll just simply keep this. So now I'll write here 30. Okay. So now we'll come to our push function. We have to insert 30. We'll come to the first step, that is top equals to top plus 1. Initially, the top was minus 1. Now after incrementing, my top value will be 2 again. So the top value which was pointing to 1 now will point to 2. And after incrementing, we'll come to the next step, that is stack of top equals to 30. So again, stack of top. What is the top value? 2. So stack of 2 equals to 30. So this 30 will be inserted to stack of 2. Stack of 2 is at my this index. So stack of 2 equals to 30. So this 30 will be inserted to stack of second index. This is how the push operation is going to perform every time we insert an element into stack. So after this, if we insert one more 40, my top will be incremented to 3 and this 40 will be inserted to third location. If again I have to perform one more push operation, my this top value will also get incremented and I can able to save here, suppose 50. So now next important thing is that currently the top is pointing to 4 and this 4 is nothing but the max size of our stack. So in this case, suppose if we have to perform one more push operation, we won't be able to perform it because our stack has reached to its maximum size, that is 5. There is no any space left in our array or in our stack so that we can insert one more element. So this condition, this situation is called as overflow. Overflow, that is our stack is being overflowed. That means there is no place left in our stack to insert or to perform one more insert operation. So this condition is called as your overflow and we won't be able to insert new element into our stack. So this overflow condition should also be written in our push function. That means when the this push function is called, the first thing we need to check is whether my stack is full or not. If my stack is full, then I'm going to print that my stack is being overflow. If the stack is not overflow, then I'm going to insert my element into the stack. So this overflow condition is also we are going to write into push function. So I'll remove this, the unwanted part, and I'm going to bring down this little, and I'm going to write this overflow condition in this push function. So for this, I'll write if my top value. So how I'm going to check whether my stack is full or not? If my top value is pointing to max size. If my top has reached to the max size, that means my stack has become full. So same we are going to write in the condition. If my top equals to 4. Currently my maximum size is 4. So I have written as 4. If my top is equal to 4, that means my stack is overflowed. That means my stack is full. So in that case, I'm going to print here stack is full or stack is overflow. And if top is not equal, top is not pointing to 4, that means either my top is pointing to either my top will be pointing to either 3, 2, 1 or 0. We don't know whether top is pointing to which location. We are only checking whether top is pointing to top is pointing to 4. That is your max size. If top is not pointing to the max size, that means there is still space remained in our stack. So I will write here else condition. So if top is pointing to 4, that means my stack is full. Else I'm going to perform the insert operations. Now coming to the pop function. So previously we had a stack where it had values 10, 20, 30, 40, 50 and top is pointing to its max size, that is 4. So now if you have noticed, in this pop function we haven't passed any argument because there is no need to pass any argument because whatever the default value which is present at the top of the stack, that is going to be deleted. Whereas in the push function, we used to pass an argument of the data which we have to save into our stack. But in the pop operation, there is no need to give any argument or any value because whatever the element that is present on the top, that is going to be deleted. Now, when we execute this pop function, the element which is at the top, that is 50, should get deleted. To delete this element at the top, what we need to do is we need to decrement this top value from 4 to 3. That means currently the top which is pointing to 4, it should point to 3. So to decrement the top value, the first step would be to decrement the top, that is top equals to top minus 1. So the initial top value was 4. 4 minus 1 equals to 3. So this is nothing but the new value of top. So the top which was pointing to 4 after the execution of decrement, it will point to 3. After getting this new top value, now my stack will only contains elements from 0 to 3. That is 10, 20, 30 and 40 because top is my highest value. That is my maximum value. So the elements which are less than top will the only elements present in our stack. And this 50 will get removed. But before removing this element, I need to print this element so that I could understand which element has been popped out. So before decrementing this top value, first we'll print this 50. So I'll make this top to the previous stage. This was our previous stage when our top was pointing to 4. So before decrementing this top, I'll write here first a print statement, printing my stack of top, that is stack of top. So here stack of top is 4. So when I'll write like this, if the stack of 4. So the stack, our array of index 4, that is this is our array, and what is index of 4? Value is 50. So I'll write output here. My output will be 50. And after printing this 50 value, next step is to decrement the top. So now after printing the element, now my top will get decremented, and we'll assume that 50 has been deleted. Now the important thing to understand is there is no as such deletion happened in the memory. We are just changing the end position of the stack. The end position which was initially at location 4, now it is at the location 3. So this memory will only get override somewhere in the next operation. There is no as such physical deletion performed on the memory. So after performing this pop operation, suppose I have to perform one more pop operation. In that case, this print will get executed. So my next output will be 40. And after coming to the next step, that is top equals to -1, again my top will get decremented to 30, and this 40 will get removed. After performing one more operation, my next output will be 30, and this top will get decremented, and the 30 will also get removed. After performing one more operation, my output will be 20, and this top will again come to 0, and this 20 will also get deleted. Now, after performing one more operation, that is top, the answer will be, here I'll write here 10, and after this, the next step is to top -1. Now, the new top value will be, sorry, the new top value will be top equals to top -1, and this 0 will also get removed. So initially the top value was 0. Now after performing one more decrement, now the top value equals to -1. So now after this, if I have to perform one more pop operation, now this won't be able to, now this we won't be able to perform pop operation one more time, because now no any element is present in our stack, because we have reached to the end of the stack. That is, this situation is called as the stack is empty. Now, so whenever we have to perform and pop operation, the first thing we need to check is whether my stack is empty or not. If it is empty, then we are not going to perform any operation. We are going to print that stack is empty. And if the stack is not empty, in that case, we are going to perform the pop operation. So I'll write here the empty condition. So I'll bring this slightly down, and I'm going to write an empty condition. So if, now how to check whether stack is empty? If my top is pointing to -1, means if top is pointing to -1, that means no any element is present in the stack. That means stack is empty. So if top equal to -1, if it is -1, then I'm going to print stack is empty. If it is not equal to -1, then else it will print the stack of the top and it will perform the decrement. And this is your overall pop operation, where we have included the empty condition as well as the pop condition. These are the final algorithms for push as well as pop operation on the stack. In the next videos, we'll see how to implement the stack in code using C.